For the majority of this course, we've been studying probability. Now, probability is a branch of mathematics that we use to model and make predictions about what we call random or chance events. So this is anything to do with what we call the probability experiment. We are now transitioning into statistics. Now, statistics is a branch of science that uses probability to analyze data and make predictions about that data. So all of the tools that we've learned about in probability are going to come into play while we start our discussion of statistics. We're going to consider a population. Now, a population is going to be filled with different individuals. So we're going to say that the population is the group of individuals that are of interest. Now, the individuals here could be anything. It could be people, it could be cars, it could be all sorts of things. We want information about some aspect or feature of the individuals. Now, as an example, we could be interested in the height of an individual or their salary. What we are going to do is we are going to model the feature of interest by a random variable. And this is how we start to make our connection. So we'll say that xi. In this population, we are going to have n individuals. So we'll have x1, x2, all the way down to xn. We are also going to assume that the random variables are IID. They're independent and identically distributed. We don't need to make an assumption about what that distribution is yet, but we are going to assume that all of the random variables that we are studying are the same. Now, as an example of this, you could think of something that I talked about before. You could think about a sugar factory. And a sugar factory produces 1 kilogram bags of sugar. Okay, so every bag that gets produced by the sugar factory, we could say that xi will be the mass of that bag. So the bags of sugar are the individuals that we are considering here, and their mass is the feature of interest. Now, the goal of what we are doing in statistics is what's called inferential statistics. The root word here is infer. To infer means you're going to take a limited amount of information and try to say something about the whole. And what we are interested in this context is we want to know information about the population. And for example, we would really love to know things like the expected value of the random variable. So we would love to know this average mass in the bag. We would love to know things like the variance. Talk to me about the spread of values in the mass. These are called parameters. Now, parameters are values that are associated with the population, and they are some sort of number of interest. We want to determine the population parameters. Now, we always use Greek letters for our parameters, and the general notation for a parameter, we are going to use the letter theta. So theta could be any Greek letter that we've been using so far. So it could be mu for the population average, it could be sigma squared, could be anything. So how to get this sort of info? And the one key idea is that we are going to make an estimate of theta using data or information from the population. And this is the key idea in statistics here. If we've got our population, we take some sort of subset of the population. This is called a sample. You decide to choose some small grouping of the population. The sample has a size that's different from the population. There's a huge amount of work that goes into sampling, and there are many, many different sampling techniques. So when you talk about things like elections and polls and making predictions, how you collect data from your population is extremely important in getting an accurate representation. But we aren't going to delve into sampling theory in this course. The one thing that we need to know is that we will always be taking a random sample. A random sample is effectively our way of ensuring that the information we get from the random variables is always independent. And that mathematical independence comes in and it makes our lives easy. So your sample contains certain amounts of information. So you've taken some of the individuals, and essentially in our mathematical model, you've taken some of the random variables. Because your sample is size n, this list has to stop at size n. Now, each sampled random variable produces what we call data. And when you've got your sample, you can think of the random variable xi sort of like a function, and it produces data. We're going to use capital letters for the random variables, like the functions. And every time a random variable spits out a number, we are going to use a lowercase letter. We will call this the observed value. And this is just a number. In order to start making estimates, we form or construct what are called statistics. Now you have to be careful here. What is a statistics? A statistics is a new random variable formed by performing some sort of mathematical operation on random variables. Now, the simplest one that we can think of here is that the averaging. So the average is a statistic, x bar. It is formed by taking random variables. So let's say the random variables from your sample, and then adding them up and dividing by the number of observations. The reason it's called a sample average is because it stops at little n. It just takes the information from the sample. So a statistic is a new random variable. It has its own expected value, it has its own variance, it has its own distribution. We are not yet going to worry about what those things are. We're just introducing terminology. So the general notation is that we are going to use the Greek letter that we're talking about with the parameter, but we'll put a hat on it. So the sample average here is going to be X bar. Another one that we are going to talk about a little bit later is capital S squared. This is going to be what's called the sample variance. The statistic is a mathematical function, or you can think of it as a random variable. It's called an estimator. And sometimes they also like to call it a point estimator. Its job is to make estimates about population parameters. So we are going to use statistics to make estimates about population parameters. The predictions or the values obtained from estimators, they are called point estimates. They are always just numbers. So for example, the sample average is a function. So this is the random variable. It's a function. And it produces a little X bar. This is the estimate or the value.